It was on this small planet, the good Earth, in the month of May, the year 1961, that the President of the United States expressed before the Congress the belief that the exploration of space in many ways holds the key to the future of mankind. We responded in our society to the challenge raised by this belief, and in this day of immense and urgent problems on Earth, we now have in space a major new instrument for use in properly managing our environment. Continuing our technological development, greatly increasing our knowledge. Our accomplishments in space within little more than a decade have greatly stimulated our ambitions for the next decade, and we now look forward to scientific laboratories in orbit about the Earth, low-cost space vehicles for transport of men and equipment, extended exploration and investigation of our moon and of the solar system itself, there is no field of greater immediate promise than the study of our planet from space. Time and again, for instance, meteorologists have used photographs from weather satellites to help alert coastal area residents to oncoming hurricanes, thus saving lives and preventing injuries. Geologists, now able to study the Earth's features as a whole as well as in part, are detecting new stores of natural resources and better understanding the structure of our Earth. Oceanologists foresee a major opportunity for learning more about our seas, potentially a rich source of food for the world's burgeoning population. They can see, for example, that the movement of river sediments along shorelines reveals much about current patterns, which strongly influence the local sea life. They look ahead to the promise for mapping many features, for instance, tidal flats, river deltas, coastal details. There are, of course, other means of data recording, for example, infrared film such as this from Apollo 9, as well as microwave techniques and radar. With tools such as these, foresters can conduct rapid surveys of large timbered areas and can quickly detect forest fires. Agronomists can anticipate large-scale crop predictions and even the early detection of crop diseases, factors of major importance to the world's food production. In this infrared photograph of an agricultural region, overall effectiveness of land management techniques can be seen by comparing the area above the horizontal line with the area below the line. It even seems probable that ecologists can make major use of data from space to deepen their understanding of the great system of life on our planet, an achievement absolutely essential to our future well-being. There is, in short, an extraordinary number of disciplines concerned with the welfare of man in his environment that will benefit by data from space. Also benefiting greatly are American technology and industry. Indeed, more than 2,500 technological innovations have emerged directly from the space program, and an immeasurable number have been stimulated by the program. The fuel cell, for example, a long-neglected power source which was revived and developed for use in spacecraft, can now fill the role of a commercial power source. This is especially exciting since the fuel cell produces no pollution. Systems developed to monitor the physical well-being of astronauts are now being adapted for use in hospitals, saving time for overworked medical specialists. Hundreds of potential pressure suit and spacecraft cabin materials have been tested to determine flammability characteristics. The results are available to industry and could lead to anything from less flammable clothing to safer automobile and aircraft interiors. Life support equipment developed for use by astronauts working on the lunar surface can now fill many specialized needs on Earth. Computer technology, a necessity in dealing with the growing complexities of modern life, was greatly accelerated to meet Apollo requirements. The 600 computers in the Apollo program comprise the largest and most advanced system in the world, and they can perform 80 billion calculations a day, a capability which can be used to help handle data from forthcoming Earth survey and scientific missions. There have also been new innovations in manufacturing techniques. For new standards of craftsmanship, quality, and precision have been injected into a major part of American industry. The result is a higher quality of products, as evidenced by the degree of success in Apollo. Looking ahead, industrialists can foresee new manufacturing processes and products which can be realized only in space. It would be possible in weightlessness, for instance, to cast perfect ball bearings, a difficult if not impossible accomplishment on Earth. These would extend indefinitely the life of rotary mechanisms, since friction would be reduced almost to the vanishing point. Additionally, new materials never possible on Earth can be produced in weightlessness. These include alloys of much greater uniformity and materials with the strength of steel and the weight of balsa wood. It would be possible to produce large, perfect mirrors and lenses, which are extremely difficult to manufacture on Earth. When a special set of satellites were launched to meet Apollo communications requirements, the stage may have been set for attaining the goal of a single international communication system. The satellites were provided by Intelsat, the International Communications Organization. The low-cost space vehicle could revolutionize global transportation, since such a craft could travel between any 2 points on Earth in less than an hour. In the midst of the space program, new companies are being formed, both to provide specialized services and to manufacture and market new products. Our international economic posture has been bolstered not only by export of new goods, but by returns from royalties, licenses, rentals, and management services as well. The material benefits accruing to our society are indeed impressive, but no more so than the intellectual benefits. Already in the wake of the space program, we have seen schools alter their curricula at all levels, greatly strengthening the scientific background of present-day students. And in basic research, we are seeing creative and imaginative men capitalize on the opportunities offered by a strong space program. Already begun are important new biological investigations, which can lead to deeper understanding of the incredible chemical complexity called life. Major and expanding studies of our sun, the ultimate source of energy for our life processes, are underway. In planning and in progress are major astronomical studies, possible only because observations are no longer obscured by Earth's atmosphere. Possible, too, are new studies in high-energy physics. These would be centered on cosmic rays, particles with thousands of times the energy we can presently duplicate in our giant accelerators on Earth. And as we explore the moon, so familiar yet so mysterious, our studies of the lunar surface, our network of scientific instruments will possibly uncover new knowledge about the chemistry of life, the nature of the moon's interior, the origin of strange new features, entirely new minerals of great value, the origin and evolution of the moon itself, primordial materials of our solar system. And in so doing, we will learn more, too, about that small planet, the good Earth.